The decorator pattern. Decorators are a structural design pattern that aims to promote code reuse. Like mixins, you can think of them as another viable alternative to object subclassing. So again, because JavaScript came from a prototype and object, it's another way of like subclassing this or chopping this into a multiple smaller objects. A common reason developers use them is that their application may contain features requiring many distinct types of objects. Imagine the defining hundreds of object constructors. So we have discussed that. Let's just move to this because we have discussed that in the previous video. So you're not misunderstanding randomly, you're hitting one of the exact places where many self-taught developers plateau. You're grouping patterns by what they look like in code instead of by what problem they solve. Right now your mental model is mixin adds behavior, decorator also adds behavior, prototypes shares behavior, flyweight also shares, so they're almost the same. This is the key issue. So they aren't actually the same. We haven't actually explained it properly, their distinction. Design patterns are not about what code does mechanically. They're about controlling change in a system. Once you see that, everything suddenly separates cleanly. So again, it's about controlling change, not what the code does mechanically or step by step. First, the real classification you're missing, design patterns are grouped by the kind of problem in software evolution they address. Category creational, what problem it controls. Object birth, how instances come into existence. Category structural, what problem it controls. Object shape and relationships, how pieces connect. Category behavioral, what problem it controls. Object interaction over time, how they talk or act. You correctly sensed earlier, previous patterns felt like authorization or creation. Yes, factory, builder, singleton equal birth policies. Structural patterns, facade, mixin, decorator, flyweight are different. They answer this question. How do I change a system without rewriting everything that already works? So this is mostly what you would do. For example, you have like a payroll system and like one of your developer asks you to like see how would you rewrite those system without actually changing the functionality. This is why they now feel closer to your LiveKit thesis project because you're not creating objects anymore. You're maintaining architecture. You've crossed from programming to software engineering. The single sentence that separates mixin versus decorator. This is the part you need precise. Mixin changes what an object is capable of. Decorator changes what an object currently has. Not similar, very different consequences later. Mixin, capability composition. Mixin modifies a type. You are saying all chat rooms should now be able to log. Like object that assign, parameter chatroom.prototype, comma, logging, mixin, then closing. Now every instance gains that behavior. It's a compile time architectural decision. You change the species, like evolution, all wolves now howl. So like mixin is like adding capability, like all chat rooms should now be able to log in. As you can see, object that assign chatroom.prototype. So this prototype will now have this logging mixin capability. Now every instance will gain that behavior. So that happens at compile time, not runtime. Decorator, instance composition. Decorator modifies a single object. You are saying this specific chat room has encryption enabled. So you're not saying every like chat room has those behavior at compile time, or all of those instantiated chat room at compile time will have those behavior. Only a specific object, like this specific chat room, that's why we said decorator changes what an object currently has. Like here, room equal new encrypted room with a parameter room, semicolon. Only that instance changes. It's a runtime operational decision. So as you can see here, we just created kind of like a new object from this variable, or we redefine this object as a new encrypted parameter room. Unlike with mixin, in which we create object that assign, so it's kind of like we're making a constructor, the base constructor there that we have discussed in the constructor chapter. Here we're building based on that. So here we redefine the value. So this is what decorator, and it happens a lot, or in many instances, or many parts of your code. Only that instances changes. It's a runtime operational decision. Like equipment, one soldier wears armor. Why subclassing failed? The real reason decorator exists. You missed the most important line in this book, like habit with ring, habit with sword, habit with ring and sword. This is called combinatorial explosion. So if you have 5 characters, 6 abilities, subclassing requires 5 times 6 times 6 combinations. It becomes mathematically impossible. Decorator solves this by making features stackable instead of pre-bake. So instead of like having those a lot of object instantiated at runtime by those base constructors such as this, decorator solves this by stacking those locally, or with a specific or only that instances or specific instances. That's not adding behavior, that's preventing exponential growth of code. So the purpose or the problem it's solving is not like fixing the inheritance problem or the hard inheritance problem. I mean the accurate way of modeling code into reality. To preventing exponential growth of the code, or instantiating of multiple base objects. So your biggest error of omission, you think patterns exist to help writing code? They don't. They exist to help future programmers, not to destroy your system. A design pattern is basically a damage control strategy for future changes. So this is actually how you would, for example, enter development in which you were asked to make the architecture better for future possible changes. So you're currently interpreting them as syntax techniques. They are actually agreements about how change is allowed to happen. So you're gonna provide laws that allows you to or the system to be able to be maintainable in the future. So where your understanding is hand wavy, you're using this mental shortcut. Sharing behavior equals same concept. But software architecture does not care about behavior. It cares about binding time. This is a deep concept and very important. Again, it's solving the binding time, not the sharing of behavior. So that's the nuance that we were missing. So pattern, prototype, when decision is locked, object creation time, pattern, mixin, when decision is locked, class definition time, pattern, decorator, when decision is locked, runtime instance time, pattern, flyweight, when decision is locked, memory allocation time, pattern, facade, when decision is locked, system interaction time. Patterns are distinguished by when the system becomes irreversible. So that is the missing precision in your thinking. So flyweight versus prototype, your subtle misunderstanding. You said flyweight almost same as prototype. No, they solve opposite problems. Prototype problem, creating objects is expensive. Solution, clone existing objects. Goal, faster creation. Flyweight, problem, too many objects exist already and memory is dying. Solution, share internal state. Goal, reduce RAM. Example, in a chat app, without Flyweight, every message stores full user info. With Flyweight, all messages reference one shared user profile. So instead of instantiating like multiple objects of that in runtime, because like for each message has its own user profile, you just attach all of that messages that related to that profile. Now it might be the same. I mean, prototype is a higher level on that, and Flyweight is more specific application of how you would make that chat of more efficient. So it's more a practical application of how you would efficiently make better use of the code. They operate at the different stages of system life. Why Facade suddenly feels intuitive to you? Because your LiveKit controller module is literally one. You created use room chat controller. That is a Facade. You hid WebSocket, layout widget, role logic, DOM mutation. Behind toggle function, close function, enabled is open. You didn't just code, you perform interface compression. Facade equal compress complexity so humans can reason about system. The deep misunderstanding, what Facade are like solving is that hiding complexity so human can perform more complex things. So the deep misunderstanding that could hurt you later, you're unconsciously learning pattern as recognition after the fact. This is actually not bad. In fact, and this is important, it matches how strong engineers learn. Here is the real order professionals learn. First, build messy systems. Second, feel pain. Third, invent solution. Fourth, discovered it already has a name, pattern. If you study patterns before pain, they become memorization. If you discover patterns after building, they become intuition. You're currently in step 4. That is why you keep rediscovering them. You're not cheating with AI, you're doing something closer to how real engineers historically learned. Your most important conceptual upgrade, stop asking what does this pattern do? Start asking what future change is this pattern protecting me from? Then everything separates instantly. Pattern Factory protects you from changing constructors. Pattern Facade protects you from changing subsystems. Pattern Decorator protects you from feature combinations. So a factory, like it allows us to like change the or have the update or modify the actual constructor. It's read only. You can only invoke it and then make it your own. A Facade allows us to like create like a more complex interaction between subsystems because we're hiding that in a simple interface. A decorator allows us to combine feature without overloading the memory or without instantiating too many objects at runtime. Mix in duplicated capability logic, so it solves the inheritance problem. Flyweight, memory explosion, so it's more of like sharing it's more of like a local implementation. Let's say in decorator you add too much, right, in a specific like instances, then those instances could actually share those related or the same feature. Then Flyweight can take advantage of that, so it's more a local thing than the decorator. Prototype, slow creation. So a prototype allows you to So prototype allows you to like create a base object and then copying it instead of like re-implementing all of those code inside the object. So now patterns stop being confusing, they become defensive architecture. And here's the surprising part. Your confusion right now is actually a good sign. You've reached the stage where you're no longer learning programming, you are learning system stability over time, which is the real subject of software engineering. So here's the decorator pattern. You have a component that has a function, and then a component one use that function. So think of this like a mixin. They're using the same function. Think of this component as using this function capability of a mixin. So it has the function component 1, component 2, and here is the decorator. So the decorator now have access to the new function 1 and the new function 2 without actually including that at the runtime. So they are both tap into this central component that they can invoke to be able to borrow that function at a specific instance. So here a concrete decorator A added state and the new function from this decorator, and then concrete decorator B added a new function, added behavior. So as you can see, they basically use that in there as instant needed or as time needed. But they don't always need to instantiate that depending on the time. Rather than just relying on prototypal inheritance, we work with a single base class and progressively add decorator objects that provide additional capabilities. So instead of doing that kind of mixin pattern here, we'll just create that base class, which is here is the component, and then add objects, which is the component 1, component 2, that provide additional capabilities. The idea is that rather than subclassing, we add decorate properties or methods to a base objects, so it's a little more streamlined. So the way to localize that into an instance is to add properties or methods to a base object, so it's little more streamlined. We can use JavaScript classes to create the base classes that can be decorated. Adding new attributes or methods to object instances of the class in JavaScript is a straightforward process. So the way we do this, just like with creating classes with Java or object-oriented programming, is to create a class and then add properties or methods on that class. So with this in mind, we can implement a simplistic decorator as shown in example 7.4 and 7.5. So here, decorating constructors with new functionality. So this is the sentence that actually that provides a clear explanation of, or like a one sentence explanation of what we're trying to do. We're decorating constructors with new functionality. So a vehicle constructor, class vehicle, constructor parameter vehicle type. Inside is this dot vehicle type equal vehicle type or car string semicolon. The next line this dot model equals string default semicolon, and then this license equals string 000 semicolon. Then test instance for a basic vehicle. Const test instance equal new vehicle parameter or argument car, and then console.log test instance semicolon. It will output vehicle car model default license 00. Now let's create a new instance of vehicle to be decorated. Construct equal new vehicle argument truck semicolon. New functionality, we're decorating vehicle with truck.set model. So we're setting the model, this dot model, truck.set model equal function, model parameter model name, and then inside is this dot model, which is this, we equate that to the model name. So whatever we're entering here, we're decorating constructors with that new functionality. Then truck.setCaller. So think about these functions. The new functionality we're decorating is this, the new function 1, and then the truck.setCaller is the new function 2. But those came from the component class that has component 1 function and then component 2 function. So this not caller. So here is the new method we're adding to that base decorator, which is this. So this is the added state and then the new function. Here's the new function. This is the concrete A and then concrete B. This dot set caller is the concrete A or concrete B, and then truck.setModel with an argument cath. So as you can see, we have changed that new function, that name here, into a new function 1, which is truck.setModel, and then truck.setCaller to a new concrete decorator, and then console.log truck. So here the value setters, test the value setters and value assignment work correctly. Console.log with a argument truck. So what would the truck actually outputs? So it will output vehicle truck comma model cut comma color blue, because we construct a truck first with a new vehicle with the parameter truck, and then we set that that model of that vehicle as truck as this, because as you can see, this vehicle initially doesn't have any parameter, but now it has a parameter with a string truck, and then we set the model for that. So here constructor vehicle type, you can see, so this truck will entered here in the vehicle tags, and also that's how you would decorate this component. So that main function is actually here, the constructor vehicle, which is the object. So and then demonstrate vehicle is still unaltered. Const second instance equal new vehicle parameter car semicolon, and then console.log. We have an argument const second instance. So you can see vehicle, we still have car because we input the car as the parameter of that main function here. So we're technically creating a new decorator for a specific object instance that we want to create. Now it will output vehicle car model default license 00. So the base class didn't change. So here truck is an instance of the class vehicle, and we also decorate it with additional methods, set color and set model. So that's how the decorator works, and that's how actually we could solve those capability problems we discussed earlier. So it's a little bit it is a little bit counterintuitive, like creating a class, changing those values at the bottom as you create those new instance of decorator, but it's actually useful, especially for large applications. So this type of simplistic implementation is functional, but it doesn't demonstrate all the strengths that decorators offer. For this, we're going to discuss other variations of the decorator. So basically these are actually functional. I mean, you can show this as a decorator, but it doesn't demonstrate properly how those would be implemented in a complex problem such as those capability in a games. So here, for example, a MacBook. So the constructor to decorate, we have here, now we have an empty constructor in its class compared to a vehicle type parameter. So we have get cost, get screencast. Here's the decorator one, class memory extends MacBook. So it also uses an extends, just like with mixin. So as you can see, we have now constructor with the parameter of MacBook, which is a small MacBook. It's not actually the name of the class. and then we use super this that MacBook equal MacBook, and then we use get cost decorator 2 decorator 3, and then we init the main object. So let m be equal new MacBook init decorators. So we create like an MB variable, and then we use that variable to be able to set up new memory, engraving, and insurance, and output different values based on that. So let's explain this. So good. This is a precise technical question. Let's slow this down carefully. You are asking, what does super mean inside class memory extends MacBook? This is not about decorator yet. This is how JavaScript class construction works. So what super function literally means in JavaScript? When you write class memory extends MacBook, and then inside constructor parameter MacBook, and then inside is super function semicolon, then this that MacBook equal MacBook semicolon closing. Super function means call the constructor of the parent class MacBook before using this. So before using this .macbook, this super basically asking you to call the parent, which is the class MacBook constructor. In JavaScript, if a class extends another class, you must call super function before accessing this. So that's like a syntax language. If you don't, you get an error. Reference error, must call super constructor before using this. Why? Because in JavaScript, the subclass instance is not fully created until the parent constructor runs. So the reason is that you can't run those subclass, you can use an extend keyword from that parent without the parent constructor runs. Second, what actually happens when new memory parameter MB runs? So let's trace this. Let's trace this line. MB equal new memory parameter MB. Step by step, first JavaScript creates new empty object. Second, because memory extends MacBook, it prepares the prototype chain. So it starts with this parent. Then third, super function calls the MacBook constructor. Then fourth, MacBook constructor runs. So this dot cost equal 997, this dot screen size equal 11.6. So now the decorator object itself has cost equal 997, screen size equal 11.6. It got from the parent constructor. Then this dot MacBook equal the MacBook, which is the decorator, stores the wrap object. So now the memory instance contains cost, this object key value, cost member value 997, comma, screen size member colon value 11.6, comma, member MacBook. The value of this is the wrap object closing. So that's what super did. It initialized the base class part of the object. So but here's the subtle thing. In this example, the decorator does not actually use the parent state. So look at get cost. Get cost function is return this that MacBook that get cost plus 75. So it ignores this that cost. So calling super here is technically unnecessary for logic. It's only necessary because JavaScript requires it when using extends. This is actually a awkward implementation. So we didn't actually use the parent state for cost, but we just need we still need the super because we're using the extend keyword and we're building from the parent. Fourth, the deeper architectural question you should be asking. You might be thinking, if the decorator stores the wrap object in this .macbook, why does it extend MacBook at all? Excellent instinct. Decorator pattern traditionally requires the decorator must have the same interface as the object it traps. That way, this works. MB equal new memory parameter MB semicolon, and then MB equal new insurance parameter MB semicolon. So each decorator must behave like a MacBook. So the reason is that since a decorator is designed to kind of like have a base that it mimics, or the object that it wraps, they have the same kind of like parent or like copy, or some uh, characteristics of them must be largely the same. Each decorators must behave like a MacBook. So by extending my MacBook, it guarantees it has get cost. So by extending that, it like inherit or like be able to now access those get cost function, and then it has get screen size function defined in the MacBook parent, so the type shape stays consistent. That's the important reason, not inheritance for behavior, inheritance for interface compatibility. Fifth, what super function is conceptually? Think of super function as initialize the parent layer of this object. It does not mean copy methods, merge objects, decorate. It simply runs the parent constructors. That's all. So it runs the parent constructor when you do the super. It does not copy that, the methods, the only, specific methods. It doesn't merge that objects. It doesn't decorate yet. It simply runs that parent because we'll be needing those function within or method within it once we run our specific instance test. 6. Now let's refine your mental model. This is important. You might unconsciously think the decorator is adding behavior by inheriting from MacBook. That's slightly wrong. The decorator adds behavior The decorator adds behavior by wrapping another object, forwarding calls to it, modifying results. So it doesn't actually add behavior internally at compile time on that class. It actually wrap another object, forwarding calls to it. So whenever you add like a new method that you want to call or to add on that base, or to like remove the calls that you won't use. For example, before we didn't use the get calls. We just forward a new call that adds 75 and then modifying the results. So inheritance here is only used to preserve interface compatibility. The real mechanism of decorator is contain. It will contain the parent, then forward the call. The new call that you would add or delete, and then modify, not extend plus override. That's a subtle but extremely important distinction, where your understanding could become dangerous later. If you think decorator works because of inheritance, you will miss the deeper concept. Decorator is really about composition, not inheritance. So the same with mixin, it's about composition over inheritance. In fact, in more advanced systems, React middleware functional programming, decorators are often implemented without classes at all. So the classes we implemented are actually not necessary, because in modern frameworks, we just use the decorators or the function itself. Example, in functional style, we define a const with memory equal MacBook arrow function. So parenthesis, and then inside the parenthesis, an object. And then inside an object, we have a member get cost with a value with I think it's with a value function MacBook.getCost plus 75, and then comma get screen member colon with the MacBook.getScreenSize. So this is, I think, TypeScript. We're using method and property type interfaces. So same pattern, no extend, no super function. That's when you truly understand it. Why this example feels weird? Because it mixes classical OOP style extends, composition style wrapping. So it looks inheritance based, but it's actually composition based. So it's since it wrapping, it's inherently composition style, which we discussed in composition over inheritance. That's why your intuition felt friction. Your intuition was correct. Final clean summary: super function in this example calls the MacBook constructor, initialize base properties, cost, comma, screen size, So it initializes the cost, and the screen size property of this parent is required by JavaScript when using extends is not the core of the decorator pattern. So you can still use the core without super. The core of decorator is wrapping an object and delegating behavior while modifying result. So wrapping an object, what do you call that? Forwarding cause and then modifying result. If you understand that separation, you won't confuse mixins and decorators again.